All right, let's dive into a massive shift that's happening right now, deep inside the data centers that power all of our AI. It's a change that starts with something as simple as a wire, but believe me, it has huge consequences for the entire future of artificial intelligence. So let me ask you a question. When you think about what's holding AI back, what's the first thing that comes to mind? For most of us, it's the chips, right? The GPUs. We're always hearing about the race for more and more powerful processors. But what if the real problem, the true speed limit holding everything back, is something else entirely?
You got it. It's the wiring. As our AI models get just exponentially bigger, the single biggest challenge has become how to move these colossal amounts of data between all those super powerful chips. The industry is hitting what they call the interconnect wall. It's like having a city full of supercars that are all stuck on a two-lane country road. The connections are now the bottleneck.
And this massive traffic jam, it's happening on highways that are all built out of copper. Now, for decades, copper has been the go-to, the reliable workhorse for any short-distance data transfer. But AI's insane demand for bandwidth is pushing copper way past its physical limits. And that's creating huge problems with signal loss, power consumption, and just pure distance.
The old industry mantra was always super simple. Use copper wherever you can and use optics, fiber optics, only where you absolutely have to. And that made sense. Copper was great for those short connections inside a server rack, but now AI factories need to connect tens of thousands of GPUs together. And for those essential, high-bandwidth, long-distance links, copper just falls apart. The signal gets weak and the power cost goes through the roof. And when I say the power cost is high, I mean it is staggering. Check this out. Projections show that by 2028, U.S. data centers alone could be drawing 580 terawatt-hours of power. A massive chunk of that energy is just being burned pushing electrons through copper wires. This isn't just some technical problem anymore. It's a full-blown, unsustainable energy crisis in the making. So, if electrons and copper are the problem, what's the solution? Well, the answer is to replace them with photons, particles of light. And this is where optical interconnects come into the picture. And they are here to fundamentally rewire the entire data center for what you might call the age of light. Optical interconnects are a total game changer. By converting electricity to light right at the source and then only turning it back into electricity at the destination, they pretty much eliminate the power cost of just moving data, no matter how far it has to go inside the data center. It's just a way more elegant and efficient way to handle data at this massive scale. Now, this whole transition isn't happening overnight. It's more of an evolution. We started with these traditional pluggable modules, but they have these really power-hungry chips inside called digital signal processors, or DSPs. So the first step in the evolution is something called linear pluggable optics, LPO, which just gets rid of that DSP to slash power and latency. But the ultimate goal, the real prize, is co-packaged optics, or CPO. And that integrates the optical engine right onto the same package as the main chip, which almost completely eliminates the distance data has to travel over copper. This chart just spells it all out. With those old-school pluggables, it takes about 15 picojoules of energy to move one single bit of data. CPO cuts that down to just 5, and there's a clear roadmap to get it below 1. That's not just a little improvement, that is a monumental leap in efficiency. I mean, in a world where power is basically the new currency, this is everything. Okay, so to really understand where these new technologies are going to go, we need to look at the two main ways AI networks are actually built. You've got scale out, which is all about connecting lots of different server racks together, and then you have scale up, which is about creating one single ultra-powerful supercomputer all within the same rack. So for those scale-out networks that connect racks all across the data center, LPO is a fantastic fit, and it's happening right now. It gives you immediate power savings and lets operators keep using those flexible pluggable modules they're used to. But for scale up, where you're trying to link a really dense cluster of GPUs together, copper hits a hard physical wall. You just can't pack enough bandwidth into that tiny 2-meter distance. And this is where CPO becomes not just an improvement, but an absolute necessity. And that is the crucial point right there. While CPO is going to benefit all kinds of networking, its first and most important job is to make these incredibly dense and powerful scale-up AI systems possible. It is the only technology that can provide the sheer bandwidth density needed to let hundreds of GPUs talk to each other as if they were one giant single brain. All right, so we know CPO is the future, but when does that future actually get here? And what are the big challenges we have to solve to make it happen?
The path is pretty clear, but it's definitely not without some major hurdles.
So the transition is already happening. LPO is here today, shipping now, providing real-world benefits. By 2026, we're going to see the first CPO products in live trials, which will help all the data center operators figure out how to work with this new architecture. But the real moment, the inflection point everyone's looking at, is around 2028. That's when CPO is expected to start shipping in high volume and become a core part of how we build the next generation of AI supercomputers.
But let's be real, this is a massive engineering challenge. Moving the optics inside the box means if one little part fails, you can't just hot swap a tiny module anymore. You might have to replace the whole board. And then there's heat. Cramming hot optics right next to an even hotter switch chip creates a total thermal nightmare. And on top of all that, the industry still needs to agree on common standards so that all these new parts from all these different companies can actually work together. I think this quote just captures the new reality perfectly. The industry is shifting from a world where optics were kind of an add-on to a world where they are the absolute starting point for any new design. For anyone building the next generation of AI systems, the mindset has to be optics first. The debate is over. The future of high-performance interconnect is light.
You know, this entire transformation, it isn't just about faster networks or more efficient data centers. By removing this fundamental communication bottleneck, we are basically uncorking the potential of AI itself. It really makes you wonder, once we've rebuilt our digital highways with light, what incredible new things will